Okay, welcome back. Hopefully you had a restful break and are ready to hit it hard the second semester. Our objective today is to solve quadratic equations using the quadratic formula. So let's go ahead, and if you have your notes from first semester, we looked at it right at the end, go ahead and pull those out. And I realize the video wasn't accessible for some of you guys, so you're going to have to start with a clean set of notes on this. So if you have them, let's go ahead and pull them out. If you don't, let's get some notes out and we'll get going on this. Remember, during any time in the video, if you're falling behind, to pause it. And if you don't quite understand something, rewind it and listen to it again. The accountability piece for this video is going to be Khan Academy. Okay, let's go ahead and begin. So the directions to this problem says, where does the function cross the x-axis? And our function is f of x is equal to negative 9x squared plus 9x plus 2. So to answer this question, we're going to use the quadratic formula. So again, where does the function cross the x-axis? Okay, if we remember or graphically what this function looks like, it's a parabola. So I'm just going to throw a parabola up here. And the question is, where does it cross the x-axis? Well, the x-axis is here. So we're talking about these points here. Now, if you remember back to first semester, these points had a different name. We called them zeros. And we determined the zero is nothing more than finding the solution to a quadratic equation. Okay, so x-axis, these are also called our x-intercepts. And by definition, an x-intercept is the value of x where y is 0. So we're going to use that concept to create an equation out of this. The value of x when y, or f of x, is 0. So our first step is to set your f of x equal to 0 and go ahead and solve this. Now, last semester, we focused heavily on factoring. Today, it's going to be about the quadratic formula. So let's go back and review the quadratic formula before we go any further. Quadratic formula says if I'm in standard form, or ax squared plus bx plus c is equal to 0. If it looks like that, like we have over here, that means descending order and equal to 0, then we can say our solutions are given by x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. And yes, you must memorize that. Okay, so what we're going to do is we're going to simply identify a, b, and c from our equation and do a substitution and do our arithmetic. So step number 1, let's identify a, b, and c. We're in our standard form in descending order, so our first term will be a, our second will be b, and our third will be c. And remember, we take the signs with it. So if it's negative, I like to circle it. So a is negative 9, b is positive 9, and c is positive 2. Step number 2, substitution. Negative b is positive 9, so I want the opposite of b. So that's negative 9 plus or minus the square root of b squared, so that's 9 squared minus 4 times a, and our a is negative 9, so don't confuse our 9s, times c, which is 2, all divided by 2 times a, which is negative 9. And that's a simple substitution. All right, our next step is to do the arithmetic. So I would like you to, in a second, pause the video and go through here and simplify every piece we can. Now, underneath the radical is where most of the simplification occurs. So go ahead and remember your order of operations. And let's write this as a single value. So go ahead and pause the video. Do that on your paper. And when you're done, start the video back up. Okay, hopefully you've arrived at an answer. We're going to go over here and figure out the answer. And what we've learned in the past is that most of the errors made when using the quadratic formula occur in this simplification piece here. So we figured out if we do it first before we look at everything else, that we make less error. So I'm going to go ahead and do that. I'm going to say, okay, I have negative or positive 9 squared. So over here I'm going to do some side work. 9 squared is 81. Then I have a negative 4. So instead of minus 4, I'm going to look at it as a negative 4, meaning I can do this, add the opposite. A negative 4 times a negative 9 times a positive 2. So negative 4 times negative 9 times a positive 2, which is positive 36 times 2, which is a positive 72. And then I'm simply going to combine them. So 81, so I'm going to move him over and write him right above. So just dragged him over. That's 3, that's 153. That simplifies to 153. So if you didn't get that correct, you didn't get 153, go back and check your work and see where you made your error so it doesn't happen on your next problems. Okay, let's go ahead and rewrite this in a simplified form. We have negative 9 plus or minus the square root of 153 all over 2 times negative 9 is negative 18. Now that's all the work required using the quadratic formula. The next step is, can I simplify my answer? Because right now I do have 2 x-intercepts. So in simplifying a quadratic using, or sorry, simplifying using the quadratic formula is usually done in 2 steps. The first thing we look for is, can I simplify the radical? Is there or does a square root of 153 exist? So I'm going to come down here and go square root of 153. I know right away it's not a perfect square, but maybe there's a perfect square as a factor, so it can be simplified. Let's go ahead and take a look. And that can be done using a factor tree. Okay, so using a factor tree, I can see that 3 goes into this 51 times. 3 goes into 51 17 times. 3 is prime, 3 is prime, and 17 is prime. So we're done with our factor tree. Now what I'm looking for to see if I can simplify are pairs. Pairs are perfect squares. It rhymes. Pairs are perfect squares. That means the square root of 153 can be rewritten as the square root of 3 times 3, which is 9. So the square root of 9 times the square root of 17. And what is the square root of 9? Well, being a perfect square, we know that guy goes to 3. This is 3 square roots of 17. So again, pairs are perfect squares. We're looking for all the pairs, so we can take the square root of them. Okay, if you didn't quite understand how we went from the square root of 153 to 3 squared to 17, re-listen to it. Stop the video and re-listen to this part, and we'll try it again. It's all about the pairs. Pairs are perfect squares. Another way to look at it, if it's a pair, then it comes out in front. If it doesn't have a pair, it stays underneath. Okay, moving on. So let's go ahead and simplify or put that back in our equation. So negative 9 plus or minus 3 square roots of 17 all over negative 18. All right, so simplification, the first one was the radical. The second one is, can I factor out a common factor from the numerator to cross cancel with a factor in the denominator? So I'm going to look at the 9 and the 3, and I notice I can pull out a 3. That leaves me negative 3 plus or minus, and when you factor out a 3, that's left a 1, and we don't write the 1, so square root of 17 all over negative 18. And 3 and negative 18 can divide a common factor of 3. I'm left with a 6. So our final answer in simplified form, or the points where it crosses the x-axis, are x is equal to negative 3 plus or minus the square root of 17 all over negative 6. And keep in mind there are 2 answers there. We have negative 3 plus the square root of 17 over negative 6, and negative 3 minus the square root of 17 all over negative 6. Okay, if you understand the concept, go ahead and continue on with the assignment on Khan Academy. If you missed a piece of this or don't quite understand, go ahead and listen to it again. Okay, hopefully that helps you out.